So what have we done in the past years? What we have done was we were thinking about, we have 130,000 boilers at the moment in the field that we have sold. These are all megawatt boilers. So that means we have a huge amount of CO2 creating products in the field all around the globe, also lots in Latin America. We have several dedicated experts working there on these topics. And then we thought, okay, if we introduce now new product, that will help us, of course, but it won't be quick enough, because many of these boilers, I know some that are still from the 50s and 60s, and they are still working quite well. Perhaps a little bit of modernization, CO2 optimization. You see it here on the lower right corner. There are lots of options what you can do there with quite affordable technical solutions, but still we won't exchange all the boilers globally within a short time frame. Therefore, we came up with the idea, what can we do with the existing ones and the new ones as well? And we came up to the point, let me put on my laser pointer here so I can show you a little bit more. We thought, okay, what can we do? So step one is CO2 optimization. So we are also consulting large companies. We go to them. We have other entities of Bosch who take care of more production equipment and electricity, but we are really focused on heating and process heat, and say, what can we do with the existing systems as CO2 optimization? That is heat recovery in various different formats, recovery of condensate, so the used steam, put it back in the system, waste heat that we put into different sources to reduce primary energy consumption, and of course, intelligent controls. So we also introduced our digital efficiency assistant, who will really guide people through and tell them, hey, look, there's some inefficiency, you should do this and that, and guides them through the process until they solved it. Next step was, we were thinking about CO2 neutral boilers. So we said, okay, you have the first customers now that have hydrogen available. The first ones were from processes, so-called brown hydrogen, but in the past they simply blew it in the environment, or they lit it up and fired it and didn't use the heat because they didn't have the safe technology to burn it available. So we said, okay, we will qualify and also modify our boilers and give the surrounding conditions and figures to people that they can fire them either with hydrogen up to 100%. We have the first boilers running with 100% hydrogen in the field with customers now since nearly 2 years. Was the first one we launched in Russia. Now we also have plants in Switzerland, in Germany, and we have different types, meaning some are running 100%, some are running a mix. We have one I will show you a picture of that's in Switzerland, who uses a mix. He is absolutely relying on steam for his pharmaceutical production. And there he can switch between natural gas, hydrogen, always when it's available, and then mix those. And as a backup, he even has oil, because he says he can't afford to lose some money because his production stands still because he doesn't have steam available. So in this case, multi-fuel firing. This is all possible. We have many customers who use biogas, also biofuels. I have an example with me later, some more exotic ones from large corporations that are using it. And also in some regions, we see they have excess ethanol or some oils from, for example, fish production. And of course, it's possible to use these as well as combustible. Last but not least, here on the slide, the topic electrification. Electricity is lovely to deal with. If it's green electricity, then it's completely CO2 neutral, and you don't even need a chimney for the exhaust gas because you don't have any. And that's, of course, lovely to deal with. And then we said, how can we introduce this? We have some customers who have some electricity available, but not all the time. So we developed hybrid boilers, meaning up to 5 megawatt, we will supply heat by electricity, and we have a burner, and the customer can balance and always use what he has available at the moment. But now, the topic, of course, today, why you dialed in, is hydrogen. Therefore, I will also focus, and I will go a little bit more into detail here. And we have my colleague from engineering, Mr. Reich, in the line. So after the presentation, we will have lots of time to discuss. You can ask all your questions, and we will be happy to answer them. So let's start with the basics. Hydrogen has begun to take a vital role in many long-term energy scenarios. To achieve maximum CO2 reduction, of course, it's important to use the so-called green hydrogen. Green hydrogen meaning produced by green power, for example, from solar parks, wind parks, etc. I think it will be also important to deliver hydrogen from warm countries to colder countries, for example, Germany, and use this in the future because we have established systems, distribution networks that will have to be adapted. But basically, that's what we have been doing with natural gas over the past decades as well. As Bosch, we have realized the first hydrogen boiler project I know of, at least in the large power range, and not just research, but actual applications. And what I find coolest fact about hydrogen is instead of CO2, out of the chimney, there comes vapor from water, like clouds, and it's absolutely clean. That's really fantastic if you do it right. We will come to this later. So burning hydrogen actually sounds quite simple at the first. You put in hydrogen in a burner, mix it with air, and ignite it. But the experience from us with the first few projects we had shows that it's quite tricky if you want to do it in a safe and eco-friendly way. Currently, gas grids that we have around the world are expected, they are still analyzing, to be able to use up to, let's say, 10 to 15% of hydrogen without any adaptations or only minor adaptations. But we must be aware that the heating value of hydrogen is only 1/3 of the one of natural gas, meaning if I put 15% hydrogen in a system compared to natural gas, I will have 95% of energy from natural gas and only 5% from hydrogen, because volume-wise, I have to put in 3 times as much. If I take it by weight, it's different. Then hydrogen has the highest power density. But here in gas grids, we are mainly looking at volumes. And also, I need much more air. So that is meant here with gas volume. Because if I fire 100% hydrogen, I need 3 times as much combustion air. That means also we need to adapt systems, because normally we put in one part here, one part there. In this case, we have much more throughput. What we are talking with customers worldwide a lot is how and when will they have hydrogen available. So in case you are interested in using hydrogen in the future to reduce or eliminate your CO2 emissions for your process or heating system, we thought of different options we can offer, because not everybody has 100% hydrogen available now. And therefore, we came up with the option to say, okay, let's make our product hydrogen ready. And I think other manufacturers of other products are thinking in a similar way. So you buy a boiler, for example, today, you're going to use it for the next 30, 40, 50 years. You want to be flexible. Perhaps like look at the Netherlands, they are prohibiting new systems that use natural gas. They had some troubles locally with their own gas sourcing. Nevertheless, you can come in a situation where something like that happens. Then you are in a position with a boiler system that had cost you several 10,000s or 100,000s of dollars or euro. And then, of course, you want to keep using it. You need it to run your production. So therefore, we said, okay, we need to have modernization options for CO2-friendly fuels. we need to make and certify our products hydrogen ready, meaning you can transfer them to hydrogen later, or you can order them hydrogen firing immediately. But this is, of course, expensive. It's an investment in the future. So we said, okay, let's put the big part of this investment, the combustion part, in the future, but prepare the rest of the system and all the installations and surroundings, because that's also expensive, of course. But if you then later can upgrade it, then that's the best option, where you can flexibly choose your fuel of the future. One thing that you have to think of to have boilers hydrogen ready is oversizing the system. I told you, like, you need 3 times as much gas running through the boiler, and this is here the case, and therefore you need larger volumes. You can say roughly 10% higher throughput, or you could reduce your maximum load a little bit, try to regain some energy from waste heat recovery, so you can compensate it to keep and maintain the maximum performance of your system. And of course, you need to be flexible to include some options for the nitrogen oxide reduction measures, because of course otherwise boilers lose their certification, at least in Europe and most other countries. The question I get a lot from customers is, can I mix hydrogen in my current system? We are in contact with, of course, all burner manufacturers. They also produce some burners, especially to our specification. So, for example, for here Dreitzler with Marathon, we have just one example. We are not exclusive there. We have the case that we can mix up to 2% of hydrogen with the existing systems without major adaptations. Minor adaptations, and even up to 5% is possible with some minor changes, meaning we would have to retrofit in combustion control, mainly oxygen content based, so measuring the oxygen content in the flue gas and then adapting the fuel air mixture, and that can compensate for a lot. Also saves you some fuel. What if we want to add up to 10%? Then we have to do a little bit more. We would have to readjust the burner, put a service technician there. He has to look at the extreme points of operation, meaning with the maximum amount and minimum amount of hydrogen, and then we can adapt it. When it becomes tricky is if we take more than 10%. Then we need major adaptations because of the topics I told you before, and also we need a new certification, because it's, I told you, safety relevant equipment. And also the notified bodies will ask us to do so. I got for you some exclusive pictures. We have not published them anywhere else yet, of an example of a hydrogen burner. This is a multi-fuel burner, of course a nice Bosch boiler, and it uses as well oil, as also natural gas in yellow, and also hydrogen as fuel. And here we are mixing it. In this case, the customer needs to be flexible. He has discontinuous amounts of hydrogen, meaning he has to adapt the amount. He has the external recirculation here because he needs to have very low NOx emissions, nitrogen oxide, and therefore he has to put in some exhaust gas in the burner to cool the flame and make the nitrogen less reactive with the oxygen. And if you look at here, we pull the burner out of the boiler to give you a very detailed view inside. And here you can see it's a very complicated technology, and we also have to have several different burner heads at the same time that are working independently. And then we need the control technology to align them again so we achieve the values we want. Here's another picture, a little bit more in detail. This is one burner manufacturer that we work with on hydrogen. We are working with 3 manufacturers mainly. meaning Dreitzler, Elko, and Sake, depending on the application. And then we engineer together with them the system, that we attune it, that the set specification parameters in total are working.